And for tables, I will introduce the shortcut here. Just for tables. This is derived from, okay, when you think of K as new over original, okay, this is still always the main idea that we've covered. And so if you move stuff around, if you do some algebra, you end up with this, that the new is K times original, okay? So it's just a shortcut that makes these ones faster, okay? So you have a bunch of spheres, and a scale factor has been used to go from one to the other. But there's the original, and I'm going to highlight that one. In this particular case, the original, even if I don't tell you, is the one that's completely filled in, okay? So in this case, the original is this, the number 3, okay? So this is our original. And then you make replicas. There are 2 spheres that have been made using a scale factor that is greater than 1, and 2 spheres that have been created using a scale factor less than 1. Okay? So the original has a scale factor of 1, right? It's just that's 100%. Nothing changes. So let's fill out one at a time. So I'm going to put new sphere number 1. We're going to deal with that one right now. Okay. And the key is to figure out what scale factor was used to go from here to there. And so you check what are, like, there's the radii, right? I could compare those. Both of them are going to have an area at one point, and then both of them are going to have volume. What do they share in this particular case? They both share radius, like you know both of their radii. So to figure out the scale factor, you're going to go radius of the new, which is what, 1.35, over radius of the original. And I will just put in brackets here, right, that this is the new and this is original. Right, I kept that format intact. And I don't like decimals as a fraction, okay? So for a fraction, please get rid of the decimals. So the best way is to just divide them. 1.35 divided by 7.5, and you get K is equal to 0.18, okay? That is important. Once you have K, right, I'm going to give it a color here to stand. Once you have K, the other ones are fairly easy to figure out. Okay, so here's what I'm going to show you here. To get the area, we would get the area of the new is going to be K what times the area of the original. What needs to happen to K in this particular case? When we're dealing with areas, we're dealing with K to the power of 2 times the area of that original, in this case, surface area, right? I should talk surface area. But you get the point, I hope. It's two-dimensional. So to get the surface area of this new shape, so sphere number 1, this one right here, we're going to, just to shorten it, to give ourselves more space, we're going to take the scale factor, we're going to square it, and then we're going to multiply it by the area of the original surface area. This is 706.86. And you grab your calculator. Okay, use brackets maybe. 0.18 to the power of 2 times 706.86. So it is 22.90, and I'm in centimeters squared here. That is the surface area of that small sphere, which makes sense. It should be less, right? And so there we go. Then you go over to volume. The volume of the new shape that we're about to find is going to be K what? cubed times volume of original. This is a shortcut when you do a table like this. It just makes it a lot faster. So we take, what's our scale factor? It's 0.18. We've already determined what it is. To the power of 3. What is the volume of the original? 1767.15. Okay. So here we go. Brackets, 0.18. How do you do to the power of 3? I hope if you've been doing your homework, you came across that. I'm going to go arrow back down like that, times 1767.15. So it's 10.306, so that would be 31. And why did I do centimeters? Nobody stopped me. Can I go back here? This one? It's squared inches, right? Going from inches to inches, not centimeters. So there you have, the key was to first and foremost find your scale factor, and then we use that scale factor to determine the remaining empty boxes, right, that you needed there. I'll do one more, and then I would like you to try it. Okay, forget about this one now. This one is filled in, okay? You're with me? Number 2, sphere number 2, this one here. We don't know both radii, right? We're trying to find the scale factor, so that is our first thing that we must do. What do we know both of? We know both areas, correct? So when you do areas, it's k squared. Don't forget that. The area, surface area of the new is 254.47, and the area of the original is 706.86. What do I need to do to figure out the scale factor? Square root. So don't forget that. So I'm going to square root, here we go. So it's a little messy, but we've got a very powerful calculator. You get that, and then go second x2, copy, paste, and so my scale factor is 7.60, sorry, 0.60. Mr. Dirksen, are you okay? Okay, so you've got your scale factor, very important. Now you can go and figure out the empty boxes, okay? So I'm going to start with the radius. I'm going to simply go scale factor. I don't need to square or cube because it's just radius times the radius of the original. That's it. And that gives me 4.5 inches. I'm going to use pink or something, right? Because to emphasize, I found the scale factor. Now I'm using it to fill out the rest. Using that pattern of, right, way up here, this is the shortcut. Except for this right now as it is, it's just linear, right? K is just to the power of 1. So you have to kind of think when to square it, when to cube it. Let's do this one here. I need to go 0.60 to the power of 3 times the volume of the original. And there we have it, 381.70 cubic inches. And I'm going to highlight that the 0.6 is what I've used for all the other ones to figure out the rest. So the key is, once you have the scale factor, just use that pattern of k times whatever the original is when it comes to radius, or k cubed times the volume of the original when it comes to volume. Okay? Let's maybe do question 4 there. Do I know my scale factor? Yes, I do. Do I need to, like, I don't need to find it, folks. That's gold. That's gold. It's already given. I'm going to put a note here. K is given. So no need to figure it out. Please don't. Okay, it's already there. So for the area, to go from the original surface area to the new one, I will take my scale factor and I will square it and then multiply it by 706.86. That will give me my new surface area. And there you have it. It should be more than what you started with because it's an enlarged version. Okay? There you have it. And I'm going to highlight K because once you have it, it's really just multiply it by the original. But it might be you might have to square it or cube it accordingly. It's for the volume. Okay? I'll take the scale factor that is given, cube it, 1767.15, like that, and voila, right? There's your new volume. So I cubed it, all right, folks? I cubed it here, multiplied it by the original. Do I need to show all my work in the box? Not necessarily. You could do it outside the box. That's fine. Okay. Man, time flies. You're like not fast enough. I'm going to ask you, I know that some of you are probably just going to be like, you know what, I just want to work on that quiz. But you've got today and you've got tomorrow. If you want a bit more table practice, go to page 50 and all the way to 56. And I'm telling you this, it's not all tables. There's some review material already. And I'm kind of focusing a bit more on scale factors, not so much on measurement and Renaults and that. That's going to be on that quiz that you're doing. There's going to be a Renault question there. Comparing rates, it's going to be on there. So please try at least one table. And maybe finish this one as well. Okay, I'm going to stop here. Because you're thinking.